Okay, students, today we'll do about alkanes. Already we have done about the reactions of alkanes, chemical properties of alkanes. So today we'll do a new topic which is called conformations of alkanes. Conformations of alkanes. So what are the conformations of alkanes? As you have got isomers means the compounds which have similar formula but different physical and chemical properties. They are called isomers, and there are three types of isomerism. One is called structural isomerism, one is called stereoisomerism, and one is called conformational isomerism. So these conformations of alkane means nothing, these are some isomers. So alkane can show some conformational isomerism, and that conformational isomerism we will study in conformations of alkanes. Now what type of isomerism are called conformational isomerism? The definition is the different arrangement of atoms in space, the different arrangement of atoms in space that result from free rotation of atoms or groups about carbon-carbon bond axis are called conformational isomer, and the phenomenon is called conformational isomerism, and the phenomenon is called conformational isomerism. The different arrangement of atoms in space that result from free rotation of atoms or groups about carbon-carbon bond axis are called conformational isomer, and the phenomenon is called conformational isomerism. As you know, there are two types of covalent bond. Some covalent bonds are called sigma bond and some covalent bonds are called pi bond. And this sigma bond, you can rotate the sigma bond, but pi bonds rotation is not possible. If you rotate pi bond, then pi bond will break. So by rotating the sigma bond, you will get different structure of alkanes, and that structures are said to be the conformational isomer. For example, ethane, C2H6, can show two conformational isomers, and these are, number one is called eclipse conformation, and number two is called staggered conformation. STAGGERED, staggered conformation. So ethane, like ethane, butane also can show some conformational isomers. So first time I will show you the ethane conformations, how ethane can show the conformational isomers. So ethane can show only two types of conformational isomers. One is called eclipse conformation and one is called staggered conformation. Now in exam you will get the question like this: draw the conformational isomers of ethane. Then you have to draw this staggered conformation and this eclipse conformation. Now, one of the scientists called Newman draw the eclipse and eclipse and staggered conformations, which is called Newman projection formula. He draws the eclipse and staggered conformation of ethane. As you know, ethane formula is C2H6, and this C2H6 you can draw it like this way also, which contain carbon-carbon single bond, carbon-carbon sigma bond, CH3, single bond CH3. So Newman draw the structure like this way. This is a carbon, and the carbon contain 3 hydrogen like this. This is one hydrogen, this is another hydrogen, this is another hydrogen. So this is one CH3. I mean, this CH3 I have drawn like this, and this is the carbon, and another carbon that is present in the back side, and the backside carbon hydrogens are present like this. This is one hydrogen of backside carbon. This is one hydrogen of the backside carbon, and this is one hydrogen of the backside carbon. They are present like this. So front side CH3 and the back side CH3 is present like this. Now, as you know, this carbon and the back side carbon, they contain sigma bond, and that sigma bond you can rotate. So when you rotate this carbon-carbon sigma bond, then by fixing the first carbon, I mean front side carbon, you rotate the sigma bond. I mean, you don't rotate the front carbon, you rotate the backside carbon with the bond. So when you rotate the carbon-carbon bond, then what happens? Since the front side carbon is fixed, that's why it will not rotate. The CH3 will remain there, and when you rotate the carbon-carbon sigma bond, then the backside carbon will rotate, and if you rotate 60 degree, then the hydrogen of backside carbon comes to this position. One hydrogen will come here, I mean this hydrogen will come to this position, this hydrogen will come to this position. You will get another structure of ethane like this by rotating carbon-carbon sigma bond. This conformation, I mean, if the direction of carbon-hydrogen bond of the first carbon and second carbon is in the same direction, then it is called eclipse conformation. This is called eclipse conformation. And if the front side carbon and the back side carbon hydrogens are not in the same direction, then it is called staggered conformation. This is called staggered conformation. So ethane can show these two types of conformation. One is called eclipse conformation, one is called staggered conformation by rotating the carbon-carbon sigma bond. Now, if you rotate again 60 degree, this hydrogen will come to this position, this hydrogen will goes to this position. I mean, again you will get the eclipse conformation like this way. I mean, ethane can show only two types of conformation. One is called eclipse, one is called staggered conformation by rotating carbon-carbon sigma bond. Now, in between these two, which one conformation is more stable? I mean, which one isomer is more stable? Always remember, the staggered conformation is more stable, because here, since the carbon-hydrogen bonds are in same direction, I mean front side carbon and the back side carbon-hydrogen bonds are in same direction, that's why some bond pair repulsion take place in this eclipse conformation. So that's why it is said to be somewhat unstable. But the staggered conformation is more stable than eclipse, because this bond pair repulsion is minimum. So if you want to write why the staggered conformation is more stable than eclipse, then you can write like this. Staggered conformation staggered conformation is more stable, because the repulsion uh, between the electron cloud of sigma bonds are minimum. So in exam you will get the question like this: draw the conformational isomers of ethane, and among the isomers which one is more stable and why. Then you have to draw the eclipse and staggered conformations like this, and staggered conformation is more stable than eclipse because the repulsion between the electrons of sigma bonds repulsion is minimum. That's why staggered conformation is more stable than eclipse. So these are called conformational isomers. And like ethane, butane also can show this type of conformational isomers, but ethane can show only two conformation. One is called eclipse and staggered, but butane can show number of conformational isomers. But according to your syllabus, only ethane is required. That's why no need to draw about the butane structure. So you should know only about the ethane conformation. So ethane can show only two types of conformation. One is called eclipse, one is called staggered.